In 1983, the North Sea was one of the most hostile, unforgiving frontiers for offshore oil exploration. Frigid waters, relentless storms, and total isolation defined the daily reality. Operating in the middle of those storms was the Byford Dolphin. This massive semi-submersible rig rested on gigantic structural columns, designed to drill deep into the ocean floor while floating entirely above heavy seas. But drilling required human hands hundreds of feet below the surface. Divers endured grueling shifts in pitch-black, freezing water, surrounded by crushing pressures. To survive, these divers lived for weeks at a time inside a specialized decompression chamber mounted right on the rig. This cramped steel cylinder was constantly pressurized to 9 atmospheres, matching the exact pressure of the ocean depth, allowing them to work without the constant process of adjusting to surface pressure. This animation shows exactly what living at 9 atmospheres does to human biology. The immense external pressure forces the nitrogen gas from the air they breathe to compress and dissolve directly into their blood and tissues, the same mechanism that keeps carbon dioxide dissolved in a sealed, pressurized soda bottle. As long as the mechanical seal on that heavy steel door held, the divers were physiologically stable. Their survival depended entirely on the internal pressure matching the pressure inside their bodies. Then a routine procedure failed. A communication breakdown and a technical error caused a dive tender to release the heavy clamp on the chamber door while the interior was still holding its full 9 atmospheres of pressure. In a fraction of a second, the pressure inside the cylinder dropped from 9 times the Earth's atmosphere down to 0. This triggered a violent, explosive decompression event. Look at what happens when you instantly break the seal on a highly pressurized liquid. The gases trapped inside no longer have the weight of the pressure holding them down, and they erupt outward instantly. Because the divers' bodies were fully saturated, this violent eruption occurred within their own circulatory systems, as the dissolved nitrogen flashed back into a lethal, expanding gas. To understand the physical destruction, we have to slow time down and look at the single millisecond following the moment that door opened. The nitrogen gas underwent intravascular nucleation. Molecules expanded into large gas bubbles inside the veins, causing the blood to boil. This violent expansion separated proteins and lipids, forming solid masses. These clumped with the gas bubbles to completely block the vessels, stopping circulation. With the circulatory system instantly jammed, the brain lost its blood flow and shut down. This happened faster than the body's nerve endings could process or transmit a single pain signal. The physics of the depressurization moved faster than the biology of human perception. The victims died before they could even realize the seal was broken. The damage extended far beyond the bloodstream. The soft tissues and internal organs, also saturated with dissolved gas, expanded so violently that the cell walls ruptured from the inside out. Medical examiners later discovered that one victim's liver had turned completely white and brittle. The internal gas bubbles had expanded with enough force and friction to effectively cook the organ. But the most extreme damage came from the pressure differential itself. One diver was standing right next to the door. When it opened, he had 9 atmospheres of force pushing outward from inside his body, meeting 0 atmospheric resistance outside. The human chest cavity cannot contain that level of outward force. The internal pressure shattered his ribs and spine, violently ejecting his internal organs and throwing his spinal column out of the chamber. It was a biological explosion. In the face of a 9-atmosphere differential, physics treats the human skeleton as nothing more than a failing pressure vessel. When investigators finally accessed the rig, they found the steel decompression chamber completely intact. The forensic investigation relied almost entirely on the biological evidence to piece together the speed of the event. During the autopsies, they found dense fatty deposits lining the victim's veins. This specific chemical separation only occurs when blood chemistry is instantly shredded by rapid decompression. The evidence left no room for debate. The fluid dynamics and gas laws operating in extreme deep-sea environments are absolute, and a single procedural mistake dictates an instant biological reaction. The disaster provided a definitive, horrific data point in the history of high-pressure physics, documenting the absolute limit of biological endurance. Following the 1983 disaster, the offshore drilling industry completely overhauled its safety protocols for saturation diving. It takes thousands of tons of complex structural steel to manage the crushing pressure of the ocean depth. The human beings operating inside that steel are infinitely more fragile. Because of this accident, modern decompression chambers are equipped with strict interlocking fail-safe mechanisms. Today, it is mechanically impossible to unseal a chamber door unless the internal and external pressures are perfectly equal. The Byford Dolphin stands as a definitive benchmark for engineering in zero-margin environments. In these settings, the laws of physics function with absolute precision, delivering a physical reaction that is as indifferent as it is instantaneous.